I think I was probably in high school. For some reason, I saw there was some journal. I have no idea what the journal was, but it had like a one-page blurb about Wolfram's Mathematica, or maybe it was still called Maxima at the time, or whatever it was. And it said, oh, you can tell it to integrate this function, and it calculates this integral. And then you can tell it to factor this polynomial, and it'll factor it, and then you can calculate the limit. And I thought, oh my God, this is a program that can do mathematics. And this left a very deep impression on me at the time. And I was very interested in how you can have a program that will do mathematics for you. It calculated limits, it calculated integrals, it did all sorts of things that were not just calculate with numbers, and it was not just draw the graph of a function. It was doing like what I considered to be, as a high schooler, serious math, right? Calculating integrals. So I was always very interested in that. I mean, I actually, my first research paper is in symbolic computation. It comes from that interest on how to do some algorithm for calculating summations in symbolic form. And I think the road from there, for me, the road from there to proof assistance is more or less a straight line, because these are programs like Mathematica, Maple, Maxima, Sage. These are called computer algebra systems. They can do lots of symbolic manipulation of objects, but they don't prove any theorems. You don't know that they're really true. But if you're a serious mathematician, you shouldn't be using a piece of software and it's telling me that it calculated an integral, and I have no idea whether it's true because it's written in C++ by some Russians who were hired by Wolfram Research and are in Indiana right now. And so, yes, they're very, very smart Russians, but still, C++ code. So what would be a better way? Well, a better way would be to actually know that you also have the proofs. It works on computer algebra systems. But let's be honest, theorem provers and proof assistants offer a better guarantee and also offer the possibility of expressing mathematics that isn't just algebraic manipulation. So computer algebra systems can't really do topology, for instance.